This video is over the piecewise and quadratic review, including both graphing piecewise functions, evaluating piecewise functions, and writing equations for piecewise functions, as well as different forms of quadratics. So this is going to hit a few of the problems from this page that you may need help with, just double checking. So first step here, we're evaluating functions, and you can either do it from a graph or from a set of equations. So I'm going to start out with a set of equations. Essentially what you do is, this is your x value, you figure out which function you need to look at. So when x is 0, that falls in this category because 0 is between here. So when x is 0, y is 5. When x is negative 6, just be careful because there's two negative 6's. You want to be the one where it equals negative 6. So it's also 5. When x is 10, again, two 10's there. We want it when it's equal to 10. So 10 squared would be 100. So it's mostly being worried about these overlaps and making sure you pick the right one. Occasionally the point does not exist. It's not part of the graph. If there's a gap, but this doesn't have a gap. Okay, now we evaluate from a graph. We're looking at g of negative 3. So that would be positive 3. Again, this is your x, this is your y. G of 4, and it's undefined right where we see it, but you go down here and it's defined. They don't put a solid point there, but that is negative 2. G of 5 is 1. G of negative 20, you say, I can't see it, my graph's not big enough. Well, that's when you need to know the equation of the line. The equation of the line, it has an intercept at 0, and the slope is negative 1. So negative 1x plus 0 would be the equation. So you plug your negative 20 in there, you get positive 20. The other thing they can ask you is when f of x equals 1, what is x? So in other words, when y equals 1, what is x? So this you can have more than one answer. So you have negative 1 and 5. If it would be, where does f of x equal negative 2, then you would write your answer as a range. So you could say x is greater than 0 and less than or equal to 2 or to 4. It didn't ask that, but that question is asked on some other ones. Okay, so the last thing with piecewise functions is actually writing the equation, and so you need to use what you know here. So we have 3 sections, and my first section goes from negative 7, oops, it's off the page, from negative 7, and it's, sorry, there's an arrow down there, so it goes forever, all the way to negative 4, and there's a solid there, so x is less than or equal to negative 4. My next interval goes from negative 4 to 2, including 2, and the last interval, there's not an open circle on the graph, but we're going to put one there to clarify for you. So then we go from 2 to infinity, which is x is greater than 2. So I need to define the 3 functions that I have. I'm going to start with that one. That's the easiest. So y equals 2 there. And then I have a parabola, and it is shifted down 2. So it's x squared minus 2. And I need to look to see, I don't go over 1 up 1. Looks like I go over 1 up 1/2. So 1/2 x squared minus 2. And you're thinking about it this way. You put the vertex in there, and then you find out what a is based on the graph. The last one is a line, and I can't see the y-intercept, but I have a slope of 2, up 2 over 1. So I know it's 2x something. I know it's going to be plus. So you can either keep counting and figure out where you're at, or just find the equation of that line. And the equation of that line, pick another point, -5, 1. And so find the equation between those two. Y equals 2x plus b, and I can plug in either my original point there, or I'll plug in my other one just to see if it works. So -10 plus b equals 1, b equals 11. And that's a method that's good to know in case your graph's really big and you don't want to count all the way up. Check it out, see if it works for -4, 3. 2 times -4 is -8 plus 11 is 3. So there's your piecewise. On the back, the key on these problems is find out what form the answer should be in, and do you need to make a sketch. And so these all need to be in vertex form, and then we're going to make a sketch. So if it's this way, you need to put it in vertex form. You need to find the vertex. So the vertex is at -b over 2a. That's the x-coordinate of the vertex. The y-coordinate of the vertex, plug back in. So we have -4 squared plus 8 times -4 plus 17. Be careful there. So 33 minus 32 is 1. So now y equals x plus 4 squared plus 1. And then I need to find the a value. Well, it's the coefficient here, so it's just going to be 1. So I'll make a sketch. To the left 4, up 1. These graphs are always nice, they make it so they fit. And then over 1, up 1, over 1, up 3. You can just mirror. Try to make a curve. Be careful when you're don't forget to find that a value. So this one's going to have a different one. Let's do one of these. So now I do know the vertex here, and I know another point. So y equals a, x plus 1, because it's always the opposite sign. Let's make that 0, plus 3. To find a, I can plug in my point. So I have a times 16 plus 3 equals 11. Subtract 3. Be careful. Don't get sloppy. Some of you are getting sloppy with your algebra that you used to be so careful with. So a equals 1/2. So the answer there would be y equals 1/2 x plus 1 squared plus 3. So down here it says put in vertex form and standard form. So if I know the zeros, then y equals x plus 3 and x plus 1. A is equal to 1. You could have different a values. So there's my standard form. And then vertex form, I repeat the process up here to find the vertex. So x equals the opposite of b over 2a. Plug back in. Here would be the easiest place to plug in to find y. 1 times -1. So I have my vertex, x plus 2 squared minus 1. The last question, I'm not going to do it, but I'm going to talk about it. Put in standard form and find zeros. So put it in standard form, just multiply this out. Make sure you multiply your binomial this way or use your shortcut. To find the zeros, then you need to factor it and set the factors equal to 0. And all of these graphs you're going to sketch on the axes that are given.